So, Assalamualaikum and a very good day to everyone here and also to our lecturer. So, basically, today my name is MOHD ZABRI and I am the representative for part A for the assignment that is assigned to us. Okay, so my group mate consists of ABDULLAH HALILI, IQBAL, and also HAZIQ. But first and foremost, I want to apologize because right now I'm having a sore throat, so I have a problem with my voice. Okay, so for the assignment, we are required to produce a report and video presentation to the Lajak Laku Top Management, which is the meeting is scheduled on 30th of January in 2022 at 2 p.m. Okay, so for part A, we have to describe and summarize the sample data of the assigned Lajak Laku tablet produced in December 2021, and we have to present the observation effectively in numerical, tabular, and also graphical form. So let's go to the Excel file. Okay, so here for the Excel file, the input data here is already given from the lecture. Okay, so we have to produce a formula to produce a table. Okay, so basically for numerical form, the total number of tablet produced is 200. Okay, but the maximum value of number of tablet that is produced is 77 in the evening. Okay, so next for the average of weight. Okay, for the weight. Okay, so in the morning, evening, and night, we have 349.9983 and 349.9983 and 349.8776 respectively. And we have the total average of weight of 1049.8743 milligram. Okay, so for variance of the weight, as you can see here, the total of the variance of the weight is 574.8676 milligram. Okay, and then for the standard deviation for the weight is 41.5283 milligram. Okay, and then for the relative density, we have the total of average at 264.1469%. For the variance, we have 12.3192%. And for the standard deviation, we have 6.079%. Okay, and then for the tensile strength, we have the total of 21.4456 megapascal. And then for the variance, we have 0.1051 megapascal. And for the standard deviation, we got 0.5616 megapascal. Okay, so here we can see the formula, which is using the summation of the rho k 26 with the k 28. Okay, that's one of it, but there's still many more here. Okay, like here we have the average, here is for the variance, also here for the standard deviation. Okay, next I'm gonna present to you the tabular form. So basically the tabular form, we have the same result but in other form. Okay, so here we have found that the maximum value of the count of weight is 58 milligram at 350 until 360. Okay, and for the maximum count of relative density in percentage, we have found that the maximum value is at 36%. Okay, at 88.1 until 89%. Okay, relative density. Next one, for the tensile strength, the maximum count is at 67 for the tensile strength of 7.11 until 7.30. Okay, so from here, in the table here, I show it on how we get the value for the median, mean, okay, standard deviation, variance, maximum, and also minimum. Okay, so here I include the formula that we use. So for the mean, we have used the average. Okay, and for the median, this is the formula. The mode, this is the formula, the standard deviation, the formula, variance, maximum, and also minimum. Okay. Okay, next one, we go to the graphical form, which is the most suitable to use for presentation. Okay. Okay, so we can see here, as I said before, the maximum for the weight is 58 milligram at the 350 and 360 milligram, and the maximum count of relative density is at 36. Okay, that's 36%. 36 at the 88.1 until 89%. And the last one for the tensile strength, we have the maximum of the 72 megapascal, okay, at 6.91 until 6.10. So for part A, that's all from my part. And now I pass it to Amir HAZIQ. Thank you.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is HAZIQ bin ZULHAMLI. So I will presenting about part B, which is the question is the Food and Drug Administration FDA authority requires the weight of standard tablet produced by manufacturers should be normally distributed with 350 milligram with standard deviation of 14 milligram. Present the required analysis and comment on whether there is significant evidence that Lajak laku tablet produced in December do follow this distribution. So first, basically, for part B is divided into four parts. Is hypothesis, test statistic, decision, and conclusion. So first, for the hypothesis, this is about the hypothesis. So first, we let the X represent a tablet weight. So H naught is equal to X, following with N, and 350 is the mean, and 14 to the power of 2 is the standard deviation. So H1 is X does not follow N, 350 and 14 to the power of 2. So then we say that this tablet weight is follow this condition for distribution of N is HO and H1 it does not follow. So that next we will talk about the test statistic. This is the table for the test statistic. So I think this is divided into 8 categories. So 8 category of praise. So this is depend on the data that has been given to us. So here is the range. So from this, we will find what is PI, OI, EI, and X to the power of 2. So basically, weight of the tablet is the range. So PI is basically the probability, and here the formula probability is Z equal to X minus 350, which is the mean divided by 14 standard deviation. So we'll find the probability for each of these, and then by putting the value of X, insert this formula, and then we will get this by using the normal distribution method. And then next, we will find the OI. OI is also frequency. So as we can see, this is what we get by using the Excel. And this is data. Count is equal to the frequency. So after that, we will find the EI, which is expected frequency, is equal to N times PI. N is equal to 200, which is the total sample. So we just divide it, and then we get the value. So after that, this is S to the power of 2, which is the chi-square test. So the concept chi-square test is O prime I minus E prime I divided by E prime I. So we get the chi-square test. So proceed into the decision. For the decision from the statistic table, we get that x equal of 2, we say by using the chi-square test. X equal of 2 test is equal to 11 at 0.05 alpha and 5 degree of freedom is equal to 11.0705. So this is the value of x test, which is the total of x test. So this is x test. So the value of x test must be greater than x x power of 2 at alpha and the degree of freedom that we find in order for us to reject the SO. So based on the statistic table, the SO, the HO, H naught is failed to reject because the value of X test is less than X as alpha and V, which is 5 as 0.05 and 5. So as we can conclude that the weight of standard tablets follow the normal distribution of 350 milligram, so that we can determine that the weight of tablet, there is a significant difference between the weight of tablet. So this proves that it follows this distribution. So next part, we presented, we will proceed to the next presenter.
Hi, my name is Ahmad Iqbal bin FAUZIHANA and I'm going to explain for part C. So for part C, the question asks whether there is a significant difference between tablet weights from different shifts. So these are all the data for weight for 3 different shifts. After that, I use data analysis function in Excel to get the output for ANOVA. There are 2 different tables here. First is the summary and the second is the ANOVA table. So as we can see here, there are a total of 200 tablets as we sum up all of these 3 different shifts for morning, evening and night. So at the ANOVA table, there are 7 columns, source of variation, which are between groups and within groups. So the following table are sum of square, degree of freedom, mean of square, F calculated, p-value and F critical. So from the ANOVA table, the p-value we get here is 0.9474601 or 61. So if the p-value is greater than alpha, then H naught will not be rejected. Second one is if p-value is smaller than alpha, then it suggests the sample data provides sufficient evidence to reject H naught. So after we compare from the output summary, p-value with alpha, so our alpha is 0.05, our p-value is 0.9474607. So our p-value is greater than alpha. Thus, we do not reject H naught. So furthermore, our F calculated is 0.053985 and F critical is 3.04175303. So F calculated is smaller than F critical. And we can conclude that there is no significant difference between tablet weight from different shift. That's all from me. Thank you.
Hello, my name is ABDULLAH HALILI. I will discuss about part D where uh, we need to make a hardness table. So to make the hardness table, we need 2 variables. The first one is relative density, or we call as the independent variable. And the second one is tensile strength, or we can say the dependent variable. So using the Microsoft Excel, uh, to make a simple linear regression, the result that we get is like this table. So from regression statistic table here, we can see from the observe, we can see that we got the 200 same as this our sample. So then the intercept estimate, the value we get is 0.17 to 8, and the estimate slope here is the 0.0791. So we can say that our regression equation will be like this, which is y equal to 0.0792x plus 0.1729. Then from this table, we can get the value of correlation coefficient, which we from my table is 0.8572, where it's near to unity, which is 1. So we can say that it forms a strong positive linear relationship between relative density and also tensile strength. After that we can see from the data we can get we can check the confidence interval of relative density. So confidence interval of 95% of the relative density, we can got the first one, the low one is 0.0725, and the upper one is 0.0858. So using hypothesis test, we can get a significance of regression for relative density. Using F-test approach, hash not, we can say that a relative density are equal to 0, and hash1 is relative density are not equal to 0. We will reject the hash not if the p-value of our significant f is less than alpha, which alpha is 0.05. So you can see here our significant f we got is 5.38506 e negative 59, which we can say that the value of significant f is smaller than alpha. Of the alpha is the p-value is smaller than alpha, so we will reject the hash not. This we can say as the data provide strong evidence that linear significantly exists between x and y. Next, will see the normal probability plot. From the normal probability plot, we can see the data is randomly sketched on a straight line. So we can say the normal assumption is justified. After that, we will see the relative density residual plot. So from this plot, we can say that our residual capture are similar to 0, which we can say it. So we can say normal assumption is justified. So the last one is the relative density line fit plot. So we can see here the blue one is our tensile strength observed from our data, and the red one is predicted tensile strength. So we can say that from the predicted tensile strength here, we can say that this model is valid because we get the positive linear and have a same hypothesis that we already confirmed. So that's all for me. Thank you.